So my name is Nick Williams. I'm an architect at Perkins Eastman in Washington, D.C. And I'm part of the design team that is designing the kind of full gut renovation and modernization of this high school. So I've actually been out here a number of times. I know this building pretty well. But today I'm just going to kind of take you on a kind of a crash course through a few things. Number one is kind of myself and my background and how I got into architecture and how you can get into architecture if you want to as well. And then I'm going to talk a little bit about how we use mathematics, specifically kind of applied geometry, to design these buildings. And kind of third and lastly, I'm going to take you on a tour of the new Oakland High School through all the renderings that we did and how we developed the design. So architecture, a crash course through profession. These are actually architects. This is a kind of a famous photo from an architecture ball in the 1940s. You don't have to be like that if you choose to go into this profession. You don't have to dress up as the Chrysler Building. You can be a normal person as well. So how did I get into architecture? I grew up in a small town that was pretty much all looked like this. This is actually a picture of the town. And I grew up drawing historic buildings. I was fascinated with historic buildings, and I wanted to be a historic preservationist. So I wanted to restore old buildings, and I told my parents this when I was about a sophomore, junior in high school. They kind of laughed at me and like, do something that gets yourself a job, please. So that was, so I started looking more and more at architecture school, and it was kind of tough as a junior in high school. It's like, well, I don't know anything about what makes a good architecture school. Where do I go to college? Because architecture schools are a little bit different than a lot of majors, where the kind of traditional metrics aren't used to rank architecture schools. So it's not just Harvard, Yale, Princeton are all great. It's a little bit more difficult than that. So luckily, someone was able to put me onto this system of rankings for architecture schools called the Design Intelligence Rankings. So what I did, basically, this is the kind of gold standard for ranking architecture schools. So I just picked the top 3 and then a couple others, and just applied to them. So my list was, at the time, I'm a little old. This was in 2004. The top 3 were Cornell, Syracuse, and University of Cincinnati in that order. And then I just added Washington University and St. Louis because I went to the campus and it was pretty, I don't know, it seemed like a good idea. So I applied to all 4, and I got into all 4. Ultimately, it came down to money, and Syracuse gave me half the tuition. So I wound up going to beautiful Syracuse University in Syracuse, New York. It's a great school. I had a great time there. This is what it looks like in the nice season, and every time I visited it. It's a beautiful, verdant campus. But being upstate New York, it quickly looked like this when I got there. It pretty much snows from October onward, so I just had to kind of adapt and pick up cross-country skiing. And besides, I was studying all the time. I mean, you're just outdoors. So it's funny because we had this kind of beautiful old Beaux-Arts building, and we had our studio in it. And actually, it used to be the agriculture school. So this is the freshman studio. As you can see, it's a bit of disarray. It's a creative mess, as we like to call it. And it used to be the livestock studies room. In fact, this is where they studied cows when the school was built. And in fact, the elevator leading up to it has a green painted wall in the back because it would calm the cows as they were brought up to the livestock room. So one of the cool things about studying architecture is that in addition to all of the kind of design and history aspects of it, you get to draw a lot. You get to just stare at drawings and think about them, and you get to go abroad. Pretty much every architecture school has a study abroad component, usually in Italy or London or somewhere like that. And I just threw in a couple of pictures, and you get to my study abroad time. You get to stand on walls in Italy. You get to go to historic architectural cemeteries in Sweden because we're weirdos. Walk the streets of Copenhagen. Get lost in Brussels, and then you graduate. And this was me in 2009. I graduated from Syracuse University. Up in the back behind Out of the Orange, our awesome mascot. So from there, you graduate, and you have two paths. One of which is a Bachelor of Architecture, which is a 5-year degree, and you graduate with that, and you can start going down the path of getting licensed and becoming, a licensed architect. And the other path is a 4+2. We get a Bachelor of Science in Architecture followed by 2 years Master's of Architecture. People choose to do either or, just kind of depending on which school they want to go to and what, and just kind of what their own personal situation is. But when you finish either of those 2 degrees, you basically, in order to become a licensed registered architect, you have to work in an architecture firm for approximately a minimum of 3 years, and you have to fulfill certain kind of aspects of learning about the profession in that time, and then you have to take 6 tests. When you're done with all of that, and it takes most people way longer than 3 years. It takes a lot of people 5 or 6 or 7 or 8. Then you become a licensed architect. So I recently became a licensed architect in the District of Columbia, which allows me to, stamp drawings and be responsible for things, which is exciting and scary at the same time. So that was kind of my path in the profession, through the profession, to starting from being a kid drawing historic houses up to being a licensed architect. But so what do we actually do every day? And this is where I'm going to start to talk a little bit about how we use mathematics, because really in many ways architecture is just applied geometry. It's applied geometry plus art, plus a little bit of crossing your fingers and hoping it works. So we're gonna look at Oakton High School today because it's what I've worked on. It's where we all are. And I don't know if you guys have seen aerial pictures of Oakton High School. It's a big building. It's already a pretty big building, and we're going to be making it a lot bigger. So here's this is just kind of an aerial image of Oakton High School to give you your bearings as we go through this. So when we get a project like this, the first thing we do is we build a 3D model of the existing building. We use a software called Revit Architecture. I don't know if you guys have ever heard of it. But yeah, we build a 3D model of the existing building, and it has a little tool in it that looks like a little sledgehammer, and then we proceed to demolish pieces of the existing building. So this is a floor plan of the existing Oakton High School, showing what we're going to be demolishing in the process. And as you see, we've broken it down. There's a bunch of pieces there that say part A, part B, part C. The school's so big that it doesn't fit at a readable scale on a 30 by 42 inch sheet of paper. It actually has to be broken down into like 18 sheets of paper. So this is that same plan, but with what we're going to add to it. Your school's about 300,000 square feet. We're demolishing about 20 or 30,000 of that, and then we're adding back like 130. So I think it's like 408,000 when we're done. It's going to be real. Your school's really big to begin with. It's going to be really big, really big, when all is said and done. So we are, to give you an idea, we're actually demolishing this room. This room will no longer be here, because as a result of this room being here, this used to be a courtyard when the school was built back in the 60s. And it got filled in because they needed more space. As a result, all the classrooms that surround this courtyard have no windows, which is not great. So we are right here for reference. And what I'm going to do to kind of give you guys an idea of how we work at different scales, and also how we just kind of look at things and assemble things, we're going to focus in this center of the building. Okay? So currently this is the front door, and this is the courtyard of the planetarium. So just keep that in mind as I go to the next slide. So from that scale, we then zoom in a little bit further. As you can see, the planetarium on the left, and this new space with what looks like a staircase on the right. And this is going to be the new center of the school, the new heart of the school. We're going to call it Oakton Hall. And it's a 2-story space. It's going to be very different from anything you have in here currently. But what you can see is what you can start to see is that we have a lot of measurements on here, right? We have a ton of dimensions on these plans, because a lot of what we're doing is basically we have a grid, and we lay things out on the grid, but we don't measure things angularly. Everything is measured from point to point. So when the contractor builds it, they actually come back in. They basically have to lay out a coordinate grid of points when we have all these angled walls based on what we show on the drawings. So zooming in a little bit, one kind of scale further, This is kind of an overall plan. There's some furniture in here. You can start to get a better idea of the space. This isn't, this is kind of more of an overall layout sort of thing, but getting further down into it, every little component on this plan here. So, this ramp, this staircase, we then zoom in one more scale. And here's where we start to really, we really start to kind of add, mathematics and dimensions and start measuring things. So all of these, again, all these points are kind of chartered out on a coordinate grid that a contractor will lay out on the floor. And here we have it's a combination of that as well as taking various spot elevations as we rise up the surface. And I'll get to it in another slide or two. You'll see what this thing starts to look like in 3 dimensions. So we continue to create these kind of more and more detailed measure drawings as we kind of burrow down more deeply in scale. And then we cut sections through these spaces. So we have to kind of document it in all 3 dimensions at the same time. Then we also show it kind of from frontal view and elevation. So there's a bunch of different places and different ways that we're documenting all of these, kind of all these changes and all these dimensional characteristics of it. So then in the end, all those drawings produce that in the lower right corner. This is all of the documentation that we have to do to show a contractor.
Oh, your elbow is kind of.
Sorry. How to build that in the lower right corner. And actually, 9 times out of 10, they do build that in the lower right corner. Now, 1 time out of 10, they'll build something completely different. You'll have to catch them in the middle of it and be like, "Hey guys, you might want to back up on that." But 9 times out of 10, this is actually enough documentation in 2 dimensions, all the way back to the zoomed out plan, to create this item